Hi, welcome back to Math Success Seminar Online. So, we've been talking about adding and subtracting fractions, multiplying and dividing fractions, mixed fractions, improper fractions. So I'm just going to do a pretty detailed perimeter and area problem with mixed fractions. This side is 4 1/5 inches. This is 6 1/3 inches. So, perimeter is just adding up all the sides. Adding this side, adding that side, adding that side, adding that side. And you can always keep it that simple. Perimeter is this side. I'm going to write inches later. Plus this side plus this side plus that side. So with a rectangle, this side and that side are the same. This side and that side are the same. So it's boom, 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 boom. And now how do we add all of these up? Well, there's a couple ways. First, we can change to improper and then carry it out that way. I did mention though in the last video that there was a way to add all these together without changing to improper. Which it might be easier just to go to improper. Because you could just add all the whole numbers separately and then add all the fractions separately. But I think I actually want to do this the improper way. So we have to change all of these into their improper forms. So 6 times 3 is 18, plus 1 is 19. 5 times 4 is 20, plus 1 is 21. And we know that these are going to be the same. 19 over 3, 21 over 5. So now we cannot add all these because they need a common denominator. Well, 3 and 5 are both prime numbers anyways. And if you have two prime numbers, then your least common denominator is just those two numbers multiplied together because they're both prime. So our least common denominator is 15. So I'm going to leave myself some space. Plus I'm going to keep track of this. 15. So how do we make this into a 15? We have to multiply by 5. Whatever you do to the bottom, you have to do the top to keep it the same. Keep it equivalent. Very precise. This is a 5. We want to change it to a 15, so we have to multiply by 3, multiply by 3. Again, this is a 3, so we want to change that to a 15, multiply by 5, multiply by 5, and what you do to the bottom, you do to the top. And now we have to work all of these out. 19 times 5, if you're uncomfy with your multiplication tables, you could take this to the side. I'm just going to write it down here. 5 times 9 is 45. Then the 4 goes here, that's 95. So I can rewrite these two as 95 over 15. 21 times 3 is, let's see, 63. Yep. Again, you can take it to the side. Knowing your multiplication tables helps speed the process up. Since I have all this laid out, I'm going to erase. You can always rewind the video. So now we're here. We're adding each side up. Since all of the denominators are the same, that means all we're doing is combining the numerators together. all over 15. So now, what is 95 plus 63 plus 95 plus 63? Well, let's find out. 95 plus 63, that's an 8, so 15. Plus 95, let's see, 8 plus 5 is 13, carry the 1. Let's see, that is 15 plus 9. Or, no, not 15 plus 9, 6 plus 9, yeah. 1, that's a 2. 253, let's put the 63 on it. That's a 6, that's 3, 16. 316 over 15. So now we have an improper fraction. How do we change it back to a mixed number? Well, we're going to have to find out how many times 15 goes into 316. So in this case, since we have a pretty large number, I recommend doing long division. So can 15 go into 3? No. Can 15 go into 30? Yes. How many times? 2 times. Because 15 times 2 is 30. So we want to subtract 30 off of 31. Carry this down. How many times can 15 go into 16? It can only go in 1 time. Notice how I'm lining this up. 15 can go into 30 twice. Do that. And now 15 can go into 16, so I go to the next place. Take 15 off. I have 1 left over. So how do I translate all this into the improper form? Well, we know the quotient is going to be the whole number. The denominator is going to stay the same. And now the remainder goes in the numerator. Since we're adding inches, 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 and inches, kind of like we're breaking this rectangle and putting it in a straight line and just counting up, that means our perimeter is going to be in units of inches. Now for area, we have to multiply these two. The area of a rectangle is length times the width. So let's consider this the length. 6 1/3 times 4 1/5. But I would not recommend multiplying these as they are. You always want to change to the improper form. That way you can see what math is true, what math would lead you astray. So changing these to the improper form, that's 18 plus 1, 19 times. This is 20 plus 1, 21 over 5. And now you just multiply going across. So 19 times 21, 3 times 5. I know the denominator is going to be 15, but 19 times 21, let's see, that's a 1, or that's a 9, that's 1. I ran out of room already. That's 19. You add a 0 for going to the next spot. It's 1. It's 2 times 1, that's 3. So 399. 399. Something very important for area is actually that this is in inches and this is in inches. So we have inches times inches, which becomes square inches. Inches squared here at the end. And now we want to change this back to its improper form. And again, we can do long division. That's a 3. There we go. So how many times can 15 go into 3? It can't. How many times can 15 go into 39? Twice, because multiple of 15 is 30. You can think of 15-minute intervals for this one. We have a 9 left over. We have a 9 left over. How many times can 15 go into 99? So this is a good question. You can always think of minutes, because 15, 30, 45, 60, 75, 90. So 1, 2, 3, 4, 5, 6 times. Can go into it 6 times, which means we're going to take 90 off of this, minus 90. We're going to have a remainder of 9, and now we have 26 wholes with a W and 9 over 15 inches squared. So we're not done quite yet, because we can reduce this to lower terms. 9 is not prime, it's a composite number. 15 is not prime, it's a composite number. And there's a multiple between these that these two share. 26 and 9 over 15 inches squared. So we're going to have, just taking, let's just take the fraction portion aside. What are the prime factors of 9? 3 times 3. What are the prime factors of 15? 3 times 5. So the greatest common factor that these two numbers share is a 3, and you can see them stacked vertically right here. This 3 is uncommon, this 5 is uncommon, but these 3's are common, so this is the greatest common factor, and they cancel each other out, because 3 divided by 3 is 1. So what's left over? 3 over 5. So we can reduce this to 26 and 3/5 inches squared. So this is a example of perimeter and area. I'm not sure how important this will become, but knowing how to multiply and divide fractions, knowing how to add and subtract fractions are very important, and this is kind of good practice for that. I know there's a whole section in Pearson that deals with just these things, and maybe this can help out for the homework, just to see an example of how it's done. I mean, this was very long-winded, and you can stop the video at any point or rewind or whatever the case may be. But that's it for right now, and I will see you next time.